Uh, Good evening. Um, this is the live session for Structure, Form and Architecture, the Synergy. It's an NPTEL course. The course instructor is Professor Shubhajit Sadhu Khan, Assistant Professor in IIT Roorkee. And I am Shreya Shukla. I am the course TA for this course and I am doing PhD currently at IIT Roorkee. Today we are going to do assignments for week 5. And this is a live session for everyone to join. We will wait for 5 minutes for people to join and then we will start the session. has been 5 minutes, so we will start with the session. If people join in the between, it's fine. So, again, hello. This is the live session for structure, form, and architecture, the synergy. This is for week 5, assignment 5. We will be doing solving assignments for week 5, and the assignments we cover here are from previous year questions. They are not this year's question. They are just to help the students understand the course better. We will not be doing the questions of this week, this year. It would be previous year's question. Moving forward, so the course title has 4 important terms: structure, form, architecture, and synergy. I have discussed these 4 terms. And just for a recap, structure is any system which is used to support and transmit possible loads on the building to the ground. It gives stability, it resists stresses and strains. Form is a 3D object or building that is perceived by a viewer in space and time. Architecture is the art and technique of designing and building, and synergy means the interaction or cooperation of 2 or more organizations, substances, or other agents to produce a combined effect greater than the sum of their separate effects. So in this course, basically what is being done is we are trying to understand how structure, form, and architecture overlap, how all they interact with each other, and we are trying to understand that synergy. So in week 5, the syllabus that was covered included frame structure, arch structures, vault structures, and dome structures. So lecture number 21, frame structure. In this lecture, firstly the definition was covered. It was introduction was given about frame structure. What are frame structure? Basically a combination of structural components like beam, column, and others, and they're connected together to resist the gravity and different lateral loads. And then it was discussed how load is transferred in frame structures. Then some examples were shown, the kind of materials which are used, example RCC, steel, composite. Then it was discussed the different types of frame structures. Mainly 2 types of frame structures were discussed in this lecture: rigid frame structure and braced frame structure. Then examples were discussed, and even types of rigid and types of braced frame structures were discussed. Advantages and disadvantages were discussed. All these points were discussed. Moving on to lecture number 22, which was arch structures. Then it was arch was talked about, definition, introduction was given. That arch is a arch is a curved structural form. It carries load. It carries compressive load. It is self-supporting, another thing. Then elements of arches were discussed, how load is transferred in arches, what materials are used to make arches, examples from around the world, and then different types of arches were covered. And then different types of arches were covered. For example, triangular, round, camber, equilateral, lancet, augie, 3-centered, 4-centered, horseshoe, parabolic, catenary, etc., etc. Examples of all the types were covered from all over the world. And then moving on to lecture number 24, 23, vault structures. Again, a similar format was used as used in arch structures. Definitions were covered. What is vault was defined, how it is made of, how the load is distributed, the different elements and components of vaults was talked about, and then the kind of materials that are used to make walls. For example, earlier times, brick masonry and stone masonry was very common in creating walls. With time now, with technological developments, now we can create it in concrete, steel, in anything, in any kind of material we can. And vaults were very common and famous structures in earlier times, especially during the Byzantine and Romanesque and Gothic eras. They were very common. And then different types of vaults were discussed. For example, barrel vault, groin vault, rib vault, cloister vault, fan vault, net vault, annular vault, rampant vault, Catalan vault, others. And all these vaults were described in details. Examples were shared, and explained through images. And then, yeah, then moving on to the next uh, lecture, it was dome structures. So in dome structures, again very similar format to the arch and vault structure lecture. Definition was covered, that dome is an architectural element and it resembles a hollow upper half of a sphere. Then how the load is transferred, examples from around the world throughout the history, the elements or the components of domes like coffers, cupola, lantern, oculus, rotunda, and others. Then these elements were explained, what these elements are, what how they look like, and then some examples of these elements were given. And then it was also discussed that how dome can be made of different materials and how it has been made of different kind of materials throughout time, like mud, we know about igloos, sorry, snow, we know about igloos, mud, we know about all those domed huts that people used to stay in, brick masonry, stone masonry, wood, concrete, steel, and others. And then types of domes were discussed. For example, corbelled dome, geodesic dome, onion dome, oval dome, saucer dome, umbrella dome, cable net dome, and others. And examples of each of these types were discussed. What are these kinds of domes were discussed in detail. Then going for the last lecture of this week, it was grid structures, and again the similar format was followed: definition, elements, materials, and others. So basically a grid is a 2D structure, resting structure made of perpendicular lines. It can be straight, it can be curved. And then it was discussed how load is transferred in grid, what materials it can be made of: concrete, wood, metal, anything. And then different types of grid structures were discussed. For example, orthogonal grid, dia grid, three-way grid, woven grid. Examples of each type was discussed. Examples from history, contemporary examples, both were discussed. Advantages of grids were discussed and disadvantages were also discussed. For example, yeah, so this was all that was covered in week 5. And now we will start with mm, our questions. So this is uh, previous year questions, these are not this year questions. Yeah, these are all previous year questions, these are not this year questions. And we will start now. A wedge shaped or tapered stone used to construct an arch is called crown, vassoy, keystone, or extrados. So these 4 terms, if you have studied the lecture, you would be familiar with these terms. If you've not, we'll just discuss these terms a little so that you can understand what these terms are and be able to answer this question. So, what is a crown? A crown is basically the highest point of the extrados, or it is the highest part of the arch. So extrados here means the outer surface of an arch. Whenever there is an arch, it would be made of some material, and there would be two curvatures, one inside curvature and one of the outside curvature. So the outside curvature is called extrados, and in that extrados, the highest point is called crown. Vasoi. Vasoi is a wedge-shaped stone that is used in building arches and vaults. And if you're building an arch or any other curved shape, rectangular bricks cannot be used. Each vassoir must be precisely cut so that it presses firmly against the surface of neighboring blocks and conducts load uniformly. The central vassoir is called keystone. The point from which the arches rises from its vertical supports is known as the spring or springing line. During construction of an arch, the vassoirs require support from below until the keystone has been set in place, and this support usually takes the form of temporary wooden centering. So in any arch or vault, these wedge-shaped pieces are called vassoirs. The central or the top vassoir is called keystone. The bottom vassoirs are called springers, and the other regular elements are called vassoirs. Keystone. So the wedge-shaped unit which is fixed at the crown of the arch is called keystone. A keystone is a wedge-shaped stone at the apex of a masonry arch, or typically round-shaped one at the apex of a vault. And in both cases, it is the final piece placed during construction, and it locks down all the stones into position, and it allows the arch or vault to bear weight. In arches and vaults, such as chalcedomes, keystones are often enlarged beyond the structural requirements, and they are often decorated also. Extrados, as I just explained, it is the outer surface of an arch or the outer curve of the arch ring. For example, if you see this figure here, the orange part that is highlighted is extrados. This is just an image which is showing different parts of the arch. What is intrados, what is extrados, what is crown, what is span, and what is abutment, what is rise. So our question was, a wedge-shaped or tapered stone used to construct an arch is called, and as we just discussed all the four terms, the correct answer would be vassoir. All the wedge-shaped stones that are used in constructing an arch or a vault are called vassoirs. Keystone is the apex vassoir, center vassoir, and the vassoirs that are on the edge, both edges, sitting on the abutment, are called springers. Moving forward, question number 2. In dash, columns and beams are made monolithically and acting together to tolerate the moments created due to imposed load on structure. And the four options that have been given are pneumatic structure, folded plate structure, rigid frame structure, and braced frame structure. So pneumatic structure is a membrane structure that is stabilized by the pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. These structures are supported by pressurized air within the inflated building elements that are shaped to carry loads in a traditional manner. The roof membrane of the pneumatic structure is made from rubber or reinforced film and ETFE foils sometimes, using industrial fabrics coated with polymers. Folded plate structure. A folded plate structure are assemblies of flat plates or slabs, and they are inclined in different directions, and then they are joined together along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need for additional supporting beams along the mutual edges. This technique originated in Germany in the 1920s, and it has become quite popular, and it is being used to construct roofs for industrial warehouses and public buildings. And modern folded plate building structures are typically made of cast in situ or precast reinforced concrete or steel plates. Rigid frame structure and braced frame structure. Rigid frame structure consists of linear elements like beams, columns, and the word rigid basically means the ability to resist the deformation. It is used in steel and reinforced concrete buildings. Rigid frames are characterized by the lack of pinned joints within the frame and typically statically indeterminate. A rigid frame is capable of resisting both vertical and lateral loads by bending of beams and columns. And stiffness of the rigid frame is provided mainly by the bending rigidity of beams and columns that have rigid connections. A braced frame structure. Braced frame structures are composed of beams and columns that are pin connected with that are pin connected with bracing to resist lateral loads. So what happens, how is braced frame different than rigid frame is that rigid frame has no pin structures. And while braced frame has pin structures, the columns and beams are pinned together uh, with a bracing to resist the lateral loads. The resistance of lateral forces is obtained through both horizontal and vertical bracing. Many types of bracing can be used, for example, knee bracing, diagonal bracing, X bracing, K bracing, or chevron bracing. Shear walls that resist lateral forces in the plane of the wall. And this frame system provides more efficient resistance against the earthquake and wind forces, and it is more effective than rigid frame. So going back, our question was, in dash, columns and beams are made monolithically and acting together to tolerate the moments created due to the imposed load on structure. So pneumatic structure, as we have understood, it works with the idea of compressed air, how the air is keeping the structure floated. So it is not pneumatic. Folded plate, we just learned that different plates are put together in an angle, so it is not that. And then we learned that rigid frame, everything is fixed, everything is rigid, and in braced frame the column and beam joints are braced together and they're kind of pinned together. It is not a fixed joint. So our answer would be rigid frame. Next question. An arch with a straight horizontal extrados is called as camber arch, lancet arch, ogee arch, ogee or ogee. I'm not sure which is the correct pronunciation, or catenary arch. So as we just learned in the first question what extrados is. Extrados is basically the outer surface, outer curved surface of an arch. And now they have saying that arch with a straight horizontal extrados. Right? This arch has a straight extrados, which means that the it's an arch, but it's almost straight. It is not exactly completely curved. It's a slight curve, very slight curve. That's why it is called horizontal extrados. Now we will learn what all these four arches are to be able to answer this question. Camber arch. Camber arch is an arch whose intrados, though apparently straight, has a slightly concave curve upward. So what happens in camber arch is that the extrados is completely straight and the intrados is slightly, a very slight curve, almost straight but a very slight curve. Lancet arch. So the lancet arch is a variety of pointed arch in which each of the arcs or curves of the arch have a radius longer than the width of the arch. So do you understand what that means? So basically they're saying that all arches that we draw, when you're drawing those arches, when you're constructing those arches, when you're preparing drawings of these arches, we all know they're made out of curves, different kinds of curves. So you will have focal points of each of the curve of these arches. So what happens in lancet arches, that the radius of the arch, if you can see the image here, the radius of the arch, for example, this is my curve and this is my radius, this is my arch, and for this curve the radius is here, which is far away from the arch end. So basically what is happening in lancet arch is that the radius is more than the width of the arch. So the radius of the curve has more is more in size than the width of the arch. That's why we get this shape. Augie arch, and in augie arch there are 4 curves that are involved. An arch with a pointed apex, and because of these 4 curves, the resultant figure has a pointed arch, and this kind of arch is very common in Islamic architecture, and it is formed by the intersection of 2 S curves. We are calling this curve an S curve because if you see, it is like an S. 4 curves are here with different focal points, and they are confined to decoration and not used in arcade arches. They are mostly used for decoration, and they were used only in the late Gothic period. It started with Gothic period, but it is now very common in Islamic architecture. Catenary arch. A catenary arch is a type of architectural arch that follows an inverted catenary curve. So the question was, an arch with a straight horizontal extradose is called as, and as we just discussed, that a camber arch has a slightly concave curve and a straight has a slightly concave curved intradose and a complete straight extradose. So it is a camber arch. Moving on to the next question. A dash is a continuous arched shape that may approximate a semi-cylinder in form. Annular volt, barrel volt, Catalan volt, and fan volt. So we will learn about all these types of volts. Before we do that, the question asks that this kind of volt is a continuous arch shape that may look like a semi-cylinder in form. So moving forward, annular volt is a barrel volt. So first we will discuss barrel volt so that we can understand annular volt. So barrel volt is a continuous arch shape that may approximate a semi-cylinder in form, resembling the roof of a tunnel, or may be pointed at its apex. It is typically formed by a series of arches, and barrel volts must be able to withstand the outward pressure on the lower parts of the volt imposed by the structure above. So barrel volts are basically different arches placed in distance, and it creates a semi-cylindrical form. And what happens in annular volt is that in annular volt, it is a barrel volt but in the shape of a ring. So barrel volt is basically different arches that are placed one after the other, and it creates a semi-cylinder kind of shape, but it is straight. And when that barrel volt is curved or it is a part of a ring, then it is called an annular volt. And I have shown you the example of both these volts. For example, this annular volt, a good example would be your colosseum. So there is a tiny diagram over there in the first image, if you can see. So yeah, because it is round shaped, the colosseum, so it has annular volts in that. Catalan volt. So Catalan volt is a type of low brickwork arch forming a vaulted ceiling that often supports a floor above. It is constructed by layering a first layer of light bricks lengthwise in space without centering nor formwork, and has a much gentler curve. It is basically a type of low brickwork arch and forming a vaulted ceiling, and it usually supports the floor above. Fan vault is formed by a series of concave sections or ribs that spread out from a series of spring points. The ribs of a fan vault are of equal curvature and rotated at equal distances around a central axis, and it was mostly used in Gothic architecture. So the answer is barrel vault. Question number 5. The vault type used in Great Mosque of Cordoba is barrel vault, cloister vault, rampant vault, rib vault. First we will learn how Great Mosque of Cordoba looks like, and then we will learn all these 4 types of vaults, and then we can answer this question. So this is the external image of the Great Mosque of Cordoba. The location is Cordoba, Spain. Architectural style is Islamic architecture, Gothic architecture. The architects were Hernan Ruiz Younger, Hernan Ruiz III, Hernan Ruiz the Elder, Diego de Ochoa Pravez, Juan de Ochoa Pravez. Opened in 1988 AD. It is located in the Cordoba province. It's a cathedral now. Earlier it used to be a mosque, and it is now a cathedral. Spain used to be an Islamic state before it turned into a Christian state. And this is how these under some arches inside the building looks like. One of the images. Second image is this of a detailed arch inside the mosque. Now we will discuss the 4 types of vaults that were mentioned. So barrel vault, we have just discussed what barrel vault is. It is a continuous arch shape that approximates a semi-cylinder form. It resembles the roof of a tunnel or may be pointed at its apex. It is formed by a series of arches. It must be able to withstand the outward pressure on the lower parts of the vault imposed by the structure above. And as you can see in the image I have added, this is how the barrel vault looks like. Now coming to cloister vaults. Cloister vaults are known as dome vaults, and they are dome-shaped vaults that maintain a polygonal shape in their horizontal cross-section. They arch towards the center from a constant spring point along a wall. So this is how a cloister vault looks like. Cloister vaults is basically a dome vault. When all these how it looks like a dome is being formed in this kind of vault. Rampant vault. Rampant vault is a continuous wagon vault or cradle vault. It is called a wagon vault or a cradle vault whose 2 abutments are located on an inclined plane, such as the vault supporting a stairway or forming the ceiling of a stairway. The impost on one side is higher than the impost on the other side. So rampant vault is basically there are 2 abutments, and these 2 abutments are located in an inclined plane. For example, in a normal arch, the 2 abutments are in the same plane. But in rampant vault, the 2 abutments are in different plane, because of which the arch that forms, it's like a cradle, and it is a little elliptical in shape, and it is usually used to for supporting a stairway or forming the ceiling of a stairway. Ribbed vault. So a ribbed vault or rib vault or a ribbed vault, it is an architectural feature for covering a white space, such as church nave composed of framework. So church nave basically means the typical churches that were constructed have 3 rectangles in them. The central rectangle part is called nave, and then there is a series of column here, and there is a series of column there, and then there are 2 more corridor kind of spaces after the series of column. They are called aisles. So the central aisle is basically called nave. So rib vault is basically used for covering a white space such as a church nave. It is composed of a framework of crossed or diagonal arched ribs. The crossed arch dome is one of the earliest type of ribbed vault, formed where the ribs, instead of meeting in the dome's center, are intertwined to form polygons, leaving an empty space in the center. So what happens in this basically is that various arches, uh, the various arches or ribs in this kind of vault, which has a typical dome in the center, like your cloistered dome, they all intertwine and form different polygons, and this is how it looks like. So our question was that how do the arches of Great Mosque of Cordoba look like? Barrel vault, cloister vault, rampant vault, or ribbed vault? So looking at this image, you can see that it is not a barrel vault. It is not a typical cloister vault, and neither a rampant vault. It is in fact a ribbed vault, because you can see different ribs coming out and making up polygons and leaving some space in the center, like the definition says. So the correct answer would be rib or ribbed vault. Number 6. Dash is any building with a circular ground plan covered by a dome. Coffer, rotunda, squinch, and pendentive. We will learn these what all these terms mean, and then we will be able to answer this question by understanding all these four terms. So a coffer. A coffer in architecture is a series of sunken panels in the shape of a square, rectangle, octagon in a ceiling, soffit, vault. It is a series of sunken panel. Basically, it's a grid structure. It can be in straight, it can be curved, and it looks like there are sunken panels in that. Rotunda. A rotunda is any building with a circular ground plan and sometimes covered by a dome. It may also refer to a round room within a building. Squinch. A rotunda. Sorry, the definition has been by mistake repeated here of rotunda. Squint is basically this corner that happens when arches and the side of a square meet. Pendentive. A pendentive is a constructional device permitting the placing of a circular dome over a square room, or of an elliptical dome over a rectangular room. So what is pendentive? Basically, when there is a uh, square form, any square form, it could be a room, it could be anything. Usually tombs are made like that, and then you have to place the dome over that square thing or a rectangular thing. So uh, the device, the architectural device, the construction device that is used to join the square with the dome is called pendentive. So the correct answer is rotunda. Rotunda is any building with a circular ground plan covered by a dome. And the biggest or the most famous example of a rotunda is Pantheon in Rome, which is a circular building which has a dome over it and also has an oculus over it, and the dome has coffered ceiling. So yeah, so this is a big example of rotunda. Another famous rotunda is the Capitol complex in US. Moving on to the next question. Metropole Parasol in Italy is an appropriate example of grid structure, arch structure, cable suspended tensile structure, or pneumatic structure. We will first see how Metropole Parasol looks like. We will learn some little facts about the building, and then we will see what all these kinds of structures mean and how they look like, and then we will solve this question. So this is basically how Metrosol Parasol looks like. It is located in Italy, and it is just a structure. It is basically a public space, and the structure is just there is a part of the public space. This is another image. That's a bird's eye view, and that's a human eye view to show how the structure is being made, and it is just a public space for people. So grid structure is a grid structure. A grid is a structure, usually 2D, made up of series of intersecting straight, vertical, horizontal, and angular, or curved lines, which are called grid lines. And it provides a more structure stability without using a lot of additional materials. So a grid is basically any intersecting structure that happens with intersecting lines. The lines could be vertical, horizontal, or angular. They could be straight lines, they could be curved lines. Arch structure. In architecture, an arch is an opening in a structure that is curved on top. In architecture, an arch is an opening in a structure that is curved on top and designed to distribute weight. Arches are self-supporting compressive structures stabilized by the force of gravity acting on their weight, which makes them very stable and efficient, capable of larger spans and supporting greater loads than horizontal beams. Cable suspended tensile structure. A suspended structure is a structure which is supported by cables coming from beams or trusses which sit atop a concrete center, column, or core. The design allows the wall, roof, and cantilevered floors to be supported entirely by cables and a center column. Pneumatic structure, we have discussed pneumatic structure. I'll still cover the definition. Is a membrane structure. It is stabilized by the pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. So the question was that how metropole parasol is an appropriate example of what type of structure. So yeah, so it's not an arch. If you can see, it's not an arch. It's a curved structure, but it's not an arch. Cable suspended tensile structure. It is not a cable suspended tensile structure. Pneumatic structure. It is also not a pneumatic structure. And as it is very evident from the image, this is a grid structure. It's a curved grid structure, but it is a grid structure. So our correct answer would be metro A, grid structure. Question number 8. A straight or arch structure across an interior angle of a square tower to carry a dome is called as oculus, tholobate, squinch, and pendentive. Just a second. So, by mistake, the definitions of squinch, I have copied another definition in the place of squinch. I'm just correcting it. I'm sorry for the confusion. So, yeah. So, the question was that a straight or arch structure across an interior angle a square tower to carry a dome is called as oculus, tholobate, squinch, and pendentive. We will first learn what all these terms are. Oculus. So oculus is a circular opening in the center of a dome or in a wall, originating in antiquity. It is a feature of Byzantine and neoclassical architecture. So oculus is basically there is a dome and there is a tiny opening in the dome, and that is called oculus. So Pantheon again is a very famous example of an oculus. Tholobate. A tholobate or drum is the upright part of a building on which a dome is raised It is generally in the shape of a cylinder or a polygonal prism. So usually a lot of buildings have domes on them on their top. So to support that top, the circular base, or it is called drum, is given. It could be a cylinder or it could be a polygonal prism, and that is called tholobate. Squinch. A squinch is a triangular corner that supports the base of a dome. Its visual purpose is to translate a rectangle into an octagon. A pendentif is a construction device permitting the placing of a circular dome over a square room of an elliptical dome over a rectangular room. So the correct answer is squinch. Which of the following dome type was used in Saint Sophia Cathedral in Novgorod? Umbrella dome, saucer dome, oval dome, onion dome. First, we will learn a little about Saint Sophia Cathedral in Novgorod, and then we will learn how all these four domes look like, and then we will answer this question. So, type cathedral, and located in Kremlin Park, Novgorod Oblast, Russia. The architectural style is the architecture of Russia. It was opened in 1050 AD. Height is 38 meters, and there are 5 domes in this structure. So the 4 types of domes mentioned in the question are umbrella dome, saucer dome, oval dome, and onion dome. We will just quickly see how all these 4 domes look like. Umbrella dome, also known as a ribbed dome, parachute dome, scalloped dome. These kind of domes are basically divided into curved segments that follow the elevations curve. Radial lines of structure that act as the dome's ribs extend down the springing from the apex. Saucer dome, a dome that is less than a hemisphere in form, or that shows less than a hemisphere on the exterior. So what happens in an umbrella dome is that there is a dome, and then there are ribs on that dome, ribbed lines, which and it kind of makes it look like an umbrella. So that's why it's called umbrella dome, or it is also called a ribbed dome. A saucer dome is basically a dome which is not exactly a hemisphere. So what happens in a saucer dome is that the diameter is far more wide than the height of the dome. So it's very less than a hemisphere. A hemisphere would be a proper sphere. This is a sphere, for example, and have a round thing here. So if this is a sphere, then hemisphere would be half of that sphere, which is like a semi thing. But in a saucer dome, it looks very less than a hemisphere. The height of the dome is very small compared to the width. That's why it looks like a plate. For basically, saucer is nothing but the tiny plate that is used with cup while serving tea. Cup and saucer. So it looks like a plate because it has a slight curve. It looks like from apart. That's why it's called a saucer dome. Oval dome. Oval dome may be defined as a dome whose plan or profile or both has an oval form. So in an oval dome, the plan can be oval or elliptical, or the profile can be oval or elliptical. So this is how an oval dome looks like. Onion dome. Onion dome is a dome whose shape resembles an onion, and such domes are often larger in diameter than the tholobate upon which they sit, and their height usually exceeds their width. So most important feature of onion dome is that it looks like an onion. That's why it's called an onion dome. It is a very common feature in Russia, I would say, and also in Arab countries. And the property of this dome is that the tholobate, the drum on which the dome sits, the diameter of the tholomate is smaller than the diameter of the dome. As you can see in this image, because it is getting curved over here, so the if you have a cross section of this dome, this curve is much bigger than the base on it is sitting. And the other thing is that the height is usually more than the width. Because of this shape, the height of this dome is more than the width of the dome. So these are the most important characteristics of these domes. Now going back to our question, the question was that which of the following dome type was used in Saint Sophia Cathedral in Novgorod. And if you see this image clearly, you can see it's not an umbrella dome, it's not a saucer dome, it's not an oval dome, it is clearly an onion dome. So the answer would be onion dome. So to be able to answer these kind of questions, you have to be aware of how the buildings look like, what they look like, what are their important features, because only then you would be able to answer these questions if you know how these famous buildings look like, what features they have, what prominent features they have. So if you know how they look like, then it would be easier to answer, because not always a picture would be given with a question. Moving on. Which of the following building used diagrid structure for its construction? Burj Al Arab, Swiss Re 30 Saint Mariax. It's also called gherkin. Gherkin is basically a name for pickles, cucumber pickles, and those pickles are elliptical or oval in shape, and the tar looks like that. That's why it's called a gherkin. Willistar, Chicago, Burj Khalifa. So the question is asking that which of these following buildings have used diagrid structure. So first we will see what is diagrid structure, then we will see how these four buildings look like, and then we will answer this question. So diagrid structure. So in a diagrid structure, a portmanteau of diagonal grid is a framework of diagonally intersecting metal, concrete or wooden beams that is used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. And the most famous example is Hearst Tower in New York City, designed by Norman Foster. Designed by Norman Foster, and it uses 21% less steel than a standard design. The diagrid obviates the need for columns and can be used to make large column-free expanses of roofing. So what happens basically in diagrid is that grid is used not necessarily in a straight perpendicular format. It could be used in angular ways, and that grid is basically used to structure the whole building. And with the help of this kind of structuring, a diagrid, the use of steel is very less compared to a regular column beam structure. And for example, the Hearst Tower in New York City, which is designed by Norman Foster, it uses 21% less steel than a standard design. And it also helps, this kind of structuring also helps in reducing the need of columns. And can be used to make large column-free expanses of roofing. So our question was, which of the following buildings use diagrid structure for its construction, and the four examples are given. Now we will just see the four examples. Burj Al Arab, it's located in Dubai, and it's a very famous building in Dubai. Swiss Re 30 Saint Mary Axis, it's called Gherkin, also called Gherkin, it's located in London. Willis Tower located in Chicago, and Burj Khalifa again in Dubai. So actually Burj Khalifa and Willistar, the structure that they use is bundled structure, and Burj Al Arab, if I'm not wrong, use the based structure because they have huge diagonal bracing in the structure, and it is very evident that the Gherkin, the Swiss Re 30 St. Mary Axe, is using a curved diagrid structure over here. So the correct answer would be B, Swiss Re 30 St. Mary Axe or Gherkin, or commonly called as Gherkin. Moving on to next question. Which of the following is not true for frame structure? Thickness of wall can be maintained. Construction of framed structure is speedy. Utilization of space is flexible. Prefabrication is not possible. So the question is asking which of the following is not true for frame structure. So we have to pick the sentence that is not true for a frame structure. So we'll understand what is a frame structure a little here. It is a structure having the combination of structural components, beam, column, slab connected together to resist the gravity and different lateral loads. It is capable to overcome the large forces, moments developing due to the applied loads, the imposed loads on the slab, transferred through beam and then column to lower floor and eventually to the foundation, to the soil. That's how load is transferred in frame structure. So what happens in a frame structure is basically it's a very regular structure having a beam, column and slab. It's a frame structure. We have framing and then we have the walls. It's not a load bearing structure, it's a framed structure. The thickness of wall can be maintained uniform throughout, and considerably thinner wall reduces dead load. Due to simple geometry, it consists with beam and column construction of frame structure is speedy, and construction is speedy because the geometry is very simple. It has basic column and beam, in a very typical traditional form. So the construction is very speedy. Rigid and stable frame structure could be able to resist tremendous vertical and lateral loads. So if these framed structures are rigid and are stable, they can resist a lot of dead load and a lot of lateral loads, including the seismic load. Large unobstructed space can be achieved with framed structure, and utilization of space is flexible. Large unobstructed spaces can be created with this frame structure, and utilization of space can also be made flexible with the help of that. Adaptable to almost any shape and can be used for high-rise structure as well. It is adaptable in any shape. It has been used in high-rises. A lot of high-rises use frame structures. Prefabrication is possible to make the construction easy. So these are some of the facts about a framed structure. And the question says, which of the following is not true from framed structure? Thickness of wall can be maintained, which is true. We can pick any kind of thickness of wall, and we also have the option of having thin walls, which reduces the dead load. Construction is speedy. We just learned that the construction of a framed structure is speedy because it has simple geometry, and so that's why it is a little easier to construct. Utilization of space is flexible. Yes, again it is true because we just learned that we can create large spaces, column-free spaces, with the help of frame structure, and which helps in making the space more flexible and to be utilized in a better way. So this statement is also true. Prefabrication is not possible. So this statement is not true because we just learned that prefabrication is also possible in frame structures, and it also makes the construction very speedy and very easy for frame structure construction. So the correct answer would be prefabrication is not possible, D. Moving on to the next question. Which of the following is an example of grid structure? Coffer slab, for a funicular arch, geodesic dome and space frame. So we will see what all these four terms are, and we already know what is a grid structure. A grid structure is basically any kind of structure which has intersecting lines The lines can be straight, the lines can be curved, the lines can be in horizontal, in vertical, in angular directions. So we will just see what these four types are. Coffer slab. Coffered slab is a ribbed structure with reinforced ribs in the lower zone which have mutually perpendicular arrangement. Funicular arch. Funicular structures include parabolic arch, tunnel vault, and domes. They act in pure compression and they have a rise to span ratio of 1 is to 2 is 1 is to 10 to 1 is to 2. Rise to span in the sense that the most highest point of the arch to the width of the arch, that is the span of the arch, the ratio could be 1 is to 10 to 1 is to 2. It could vary from 1 is to 10 to 1 is to 2. And the other kind of funicular structures are parabolic arches, tunnel walls, and domes. They act in pure compression. Coffered slab basically has a looks like a ribbed structure. It's a grid structure and it looks like a grid. Geodesic dome is a hemispherical thin shell structure based on a geodesic polyhedron. The triangular elements of the dome are structurally rigid and distribute the structural stress throughout the structure, making geodesic domes able to withstand very heavy loads for the future sizing. So geodesic domes are hemispherical thin shell dome structures. They're not necessarily hemispherical always, they could be spherical also, as there are a lot of examples of geodesic domes which are fully spherical in shape with a little part not in the bottom. And it is based on the properties of a geodesic polyhedron. And the entire dome is made of triangular elements intersecting, and it creates a structurally rigid curved structure. So yeah, and then space frame. Space frame or space structure is rigid, lightweight, truss-like structure constructed from interlocking struts in a geometric pattern, and space frames can be used to span large areas with few interior supports. So we all know trusses are 2D, two-dimensional structures. So space frame is a 3D truss. It has different kinds of triangular members and members, geometric patterns aligned, interlocked in geometric patterns, and it can be used for abutting large spans and other things. So our question was, which of the following is an example of grid structure? A coffer slab, a funicular arch, a geodesic dome, and a space frame. And as we can see clearly that the answer would be coffer slab, and also the correct answer would be coffer slab. However, I am also a little opinionated that I think geodesic dome may also fall in the grid structure. It is not exactly a regular grid structure, but it is I have a feeling that it's a form of diagrid structure. I will have to confirm this, and I will research a little on it, and I will clear it out in the next session. Yeah, for meanwhile, the correct answer is a coffer slab. It is a grid ribbed structure. Which of the following is which of the following is not an arch type? Lancet, camber, orgy, and focal. Camber arch is an arch whose intrados, though apparently straight, has a slightly concave curve upward, and the extrados in a camber arch is completely straight. So the question is basically which of these following is not an arch type. And then lancet is also an arch, and I have just discussed all these arches. The lancet arch is a variety of pointed arch in which each of the arcs or curves of the arch have a radius longer than the width of the arch. Augie arch will have a pointed apex formed by the intersection of two S curves, usually confined to decoration and not used in arcade arches. Ogee arches were used only in the late Gothic period. And focal points are basically where the curves of the arches originate. So of course focal is not an arch, another three are arches. So the correct answer is focal. Question number 14. A continuous vault having two abutments located on an inclined plane is fan vault, Catalan vault, rampant vault, cloister vault. So, Catalan vault is a type of low brickwork arch forming a vaulted ceiling that often supports a floor above. It is constructed by layering a first layer of light brick lengthwise in space without centering or formwork and has a much gentler curve. A fan vault is formed by a series of concave sections or ribs that spread out from a series of spring points. Uh, the ribs of a fan vault are of equal curvature and rotated at equal distances around a central axis. It is mostly used in Gothic architecture. Rampant vault is also called a wagon vault or a cradle vault, and the two abutments are located on an inclined plane, such as the vault supporting a stairway or forming the ceiling of a stairway. The impost on one side is higher than the impost on the other side. In cloister vaults, also known as dome vaults, are dome-shaped vaults that maintain a polygonal shape in their horizontal cross section. They arch towards the center from a constant spring point along a wall. So the question was that a continuous vault having two abutments located at an inclined plane is fan vault, Catalan vault, rampant vault, or cloister vault. So our answer would be rampant vault. Meridional stress developed on a dome is dash in nature: compressive, tension, bending, or shear. So we are talking about meridional stresses. So any kind of dome, when it is analyzed, it is concerned with two stresses: the stresses that are acting in the meridional direction, that is the meridian of a dome, and the stress that is acting in the parallel direction of hoop. Hoop is the circumference of the dome, and the parallels of those hoops are called hoops. So in a dome, when stresses are acting in a dome, so along the meridians, only compressive forces act or compressive stresses act. Along the hoops, compressive forces also act and tensile forces also act. So the question was that in meridional stress developed on a dome is dash in nature. So it is compressive in nature because meridians only have compressive force. Hoops have compressive as well as tensile forces. Question number 16. The constructive device which allows the placement of the circular dome over the square room is called squinch, oculus, pendentive, solobate. We have covered all those four terms. We will again cover it for a while, and I think the definition of squinch here is again wrong. I'm sorry for the mistake. Yeah, so oculus is the circular opening in the center of a dome in the wall. Originating in antiquity, it is a feature of Byzantine and neoclassical architecture. Tholobate, not Theobald, Tholobate or drum is the upright part of a building on which a dome is raised. It is generally in the shape of a cylinder or a polygonal prism. Squinch is a triangular corner that supports the base of a dome. Its visual purpose is to translate a rectangle into an octagon. Pendentive. Pendentive is a constructional device permitting the placing of a circular dome over a square room or an elliptical dome over a rectangular room. So the question of was the constructive device which allows the placement of the circular dome over the square room is called squinch, oculus, pendentive, or tholobate. Correct answer is pendentive. Moving on to the last question of today's session. What kind of rigid frame structure is the example shown below? So they have given a image, shape, and you have to identify what kind of rigid frame structure is this. Is it fixed ended? Is it pin ended? Is it roller support, or is it brace support? So roller supports are free to rotate and translate along the surface. I covered this part in the live session 3. I'm just covering it again. So roller supports are free to rotate and translate along the surface upon which the roller rests. Roller supports are commonly located at one end of the long ridges. This allows the bridge structure to expand and contract with temperature changes. The expansion forces could fracture the supports at the banks if the bridge structure was locked in place or if it was fixed. Roller supports can also take the form of rubber bearings, rockers, a set of gears which are designed to allow a limited amount of lateral movement. So basically in the roller support, it is allowed to have a movement. It is not fixed. Fixed supports can resist vertical and horizontal forces as well as moments. Since they restrain both rotation and translation as in the movement in the horizontal direction, horizontal or vertical direction. They're also known as rigid supports. This means that a structure only needs one fixed support in order to be stable. All three equations of equilibrium can be satisfied. A flagpole set into a concrete base, is a good example of this kind of support. Basically, the structure cannot move at all in this kind of support. Just a second, excuse me. So in fixed support, it is all fixed, nothing can move. That's why it's called fixed support. Pinned support can resist both vertical and horizontal forces, but they cannot resist a moment. They allow the structural member to rotate, but not to translate in any direction. It can rotate, but it cannot move up or move side. In roller support, it can move side, it cannot go up, and it cannot rotate. It can just move in this direction. In pinned support, it can rotate, but it cannot move in this direction or in this direction. In fixed support, it is not moving in this direction or this direction, and it is not even rotating. And how we showcase these supports is how it is. Roller is shown that there is a base and then there is a circle resembling a bearing. In pinned, usually there is a base and then there is a triangle to show the bin. Fixed, usually there is a base and then the structure directly starts. So these are some of the examples. The first one is a fixed support. It is just fixed there. Second one is a pinned support. It is located with a pin, so it can have a little rotational movement. Third is a roller, so that it can translate a little here and there if it needs to. So this was another diagram showing in which direction the movement is allowed and what all is restricted. So fixed support allows direction in no direction. It restricts movement in vertical and horizontal direction and also rotation. Pinned support, you can rotate, but the support about the supported location, it restricts vertical and horizontal direction. And roller support, it can move horizontally and it can also rotate. I'm sorry, I thought it did not rotate, but it can also rotate. It only restricts vertical direction. And then these are to how when we are showing a structure like a building, this is how a fixed ended would be shown and this is how a pin ended would be shown. So now our question was that what kind of rigid frame structure is the example shown below. So as you clearly see that we just learned that for pin the symbol of triangle is used, for roller the symbol of circle is used. I'm not sure what is the symbol for braced support that is used, and for fixed it is directly put on the ground. So our correct answer would be Pinendon. So now is the time for questions and queries. Since no one is in the meeting currently, I will wait for 15 minutes here to see if anyone joins the meeting and asks a question, and then I will end this session. Thank you. It has been 15 minutes. No one has joined the session, and no one has any doubts. So I would conclude the session for today. In case any kind of doubts arrive later, you can ask me in the next session. I would try to answer them as per my knowledge. If I won't be able to answer, I will learn about it and then I will answer you, because not everyone can know everything. And yeah, and see you all in next week, where we will do week 6 of this where we will do week 6 assignments for this subject: structure, form and energy, structure, form and architecture, thus energy. And yeah, thank you.